Entanglement is one of the greatest threats of whales in the modern era. It has been a matter of concern for many years and has brought more focus from the academic field in the recent years. Miguel Pisco is our next speaker. He is a master student at the University of Iceland Research Center in Húsavík. His presentation is called Close Encounters of the Twisted Kind, Non-Lethal Entanglement of Icelandic Minke Whales.
Entanglement of Icelandic minke whales. First, I'll talk briefly how entanglement poses a serious threat to cetacean species all across the world. Then, why the minke whale as a study species, and followed by some environmental, some ecology effects, and how those factors exacerbate the problems of entanglement for that study species. Certainly, after the creation of the catalog and the matching and the coding, the establishment of this criteria that I'll use to analyze both entanglement and parasite loads. And as this is an ongoing project that I will expand further, for now I'll just give you some preliminary results based on a small subset of data that I have now. And finally, some discussion points for some further studies in the future and to tackle some issues that I already found with the entanglement in these whales and in the other locations. Entanglement is thought to be the most proeminent danger in terms of welfare and cetacean survivability across the planet. It can both affect the whales in a lethal or a non-lethal way and impact their fitness. So think, for example, on the first picture, you can see that Hampack has been entangled on the fluke and also on the pectoral fins. And this can lead to drowning, and that would lead to the death of the whale. But also, it could restrict their movement, making the energy budget that this whale needs to swim. He would need to have more strength. It would waste more energy. But also, for example, feeding, especially important on baleen whales, since they have to use these big amounts of energy just to filter feed. And if the entanglement happens around the mouth area, this would impact severely feeding and, of course, it would impact reproduction and migration because the whales then have to decide to invest in either one or the other. So you can imagine maybe a whale that has been severely impaired. When he goes to the tropics to breed, then maybe you'd have to choose not to breed that year. And this, in the long term, could have an impact at the population level. And these animals that live this long and only breed every 2 to 3 years, imagine in the case of the minke whale, this can have serious consequences for their future. All in all, this entanglement have impacts on the growth and the longevity. It will both impact in a way that it will reduce their lifespan and their growth. And through another lens, welfare is a hot topic as well, since the way and the severity of entanglement can cause immense suffering to these animals. The most abundant baleen whale in Iceland is the common minke whale, and also the smallest baleen whale in the northern hemisphere, and the second smallest baleen whale in the whole world. In Iceland, a study showed that around 42,000 minke whales inhabit Icelandic waters, as you can see on the study area on the bottom picture. And although they hold a conservation status of least concerned, studies as well show that since 2001, there seems to be a declining trend on their numbers. And as I mentioned, as many other baleen whale species, their gestation periods are long, from 10 to 11 months, only having one calf every 2 to 3 years. So you can see how entanglement would impact this. But why is the minke whale different in terms of other cetaceans? Since it's one of the smallest, it's also one of the ones that it hits the hardest when it comes to entanglement, since their small size translates in a decreased capacity of the whale being able to resurface. So you can imagine if the whale it cannot come to the surface to breed, it will drown. And this brings other problems, such as underreporting, because scientists and fishermen won't be able to understand there has been an underestimation of mortality for these whales. And in Iceland, they mainly interact with longline fishing and with mid-water trawling. So as you can understand, lethal entanglement is quite hard to study. Therefore, we need an indirect method. There where it comes my study, which will focus on what is the proportion of the Icelandic minke whale population that shows signs of being previously entangled, and also what is the rate of entanglement throughout the years. This is something that has been done in Scotland but never for Iceland, and this also will give an overview on, for example, minke whale movements. For this, I'll use primarily photo identification, both from data that I'm taking now and from historical data. And photo ID is a non-invasive method using photographs to research individuals based on their distinguishable features. And the catalog itself will be comprised of all of these data that will be put to analyze the individuals throughout the years, as you can see here. And then I'll create, both for entanglement and for parasite load, criteria based on the severity and magnitude. Finally, the creation of the catalogs on different study areas will allow comparison between this one. But then how will I do this? So basically, using the minke whale body, I will create 4 main divisions. That will be both for left side and right side, the head, the leading edge and the trailing edge of the dorsal fin, so that will be the front and the back respectively, and the flanks. The tail is not included as a separated one since minke whales very, very, very rarely fluke. So all in all, it's the fluke itself. And then each photo will be assigned a value of photographic quality from 1 to 5, and only the ones that are equal or superior to 5 are being included in the scar analysis. For the catalog, basically, we have 3 main criteria to be included for their distinguishable features. Then we have body marks. As you can see on Whalard on the bottom left corner, it has this white patch beneath the dorsal fin, which is very unique. Or then, in the case of MWAL, a very distinct dorsal shape, and in the case of Sinister, a dorsal fin edge mark individual. As you can see on the back part of dorsal fin, right at the bottom, there is this massive nick, and this is something that we can use to identify them. And the rest will not be included since they don't have distinguishable features. This would be the NDEMs. For my study area, I'm currently then taking data from Husavik, while at the same time I'm analyzing photos from Akureyri, from Reykjavik, from different years. And all of this will be then converted into a massive catalog that will amass these different locations in Iceland. These criteria that are going for each body part are focused on the 2 main themes, which are the entanglement and the parasitic load. For entanglement, it ranges from a magnitude of no visible scarring to raw or fresh wounds, or, for example, cases that the fishery gear is still attached. So these are qualitative and subjective categories. And for the parasite load, it is similar since it goes from no circular parasite scarring to plus more than 11 circular. And every single category will just count the amount of parasites that I can find through the pictures on each body part. And to give you an example, how would I categorize for how to calculate entanglement? You can imagine and can focus on the 3rd row, monarch. And all of these LF, RF are regions, so this will be the flanks, the first 2, then the follow 2 will be the head, and the final 4 will be related to the dorsal fin, front and back, left and right sides. And then on the end, they receive a summary. So basically, since monarch has a nick, a notch, so like those little dents in the body, on the front part and on the back part, they are then assigned as a high probability of entanglement. Because you can imagine that a whale is more likely to get entangled from the frontal part of the dorsal fin, since they're not doing reverse sparking most of the times with the nets. And here are some examples of some of the whales that are included in my catalog and were included on the scar analysis due to their quality and due to distinguishable features. On the first one, you can see that small circular patch on the left flank, that circular scar, that is due to a parasite. And more importantly, the one on the right, that small linear black thing on the left flank, it is a parasite that is still currently attached. And these are all also differently assigned different codes, and this is how I can analyze if they have a low, medium, or high parasite loads. And for example, for the bottom ones, more related to the entanglements, these nicks and notches also get different codes. All in all, to calculate the proportion of the animals that do show signs, it's using as a more conservative, safe way. Only the ones that have a high likelihood of being entangled are then compared to the rest of population, and this will show us the safest, most conservative value, while the maximum would also include the ones that are uncertain, of uncertain value, and the same would apply for the parasite loads. So as I mentioned at the beginning, this is still an ongoing process, and so far I've analyzed for Akureyri, which has the least amount of data of all the 3 locations so far, but even with that, out of 19 whales on the catalog, and then the 13 that were identifiable, and then with the process of the photo quality, and there are around 9% of the whales that do show signs of being previously entangled. While if we include the uncertain ones, this value could skyrocket until 55%. When it comes to the low parasites, when it comes to the parasite loads, about over a third show signs of having scars that are related to parasites. And it is important to remind that even though these numbers might change with more data added, through visual inspection already, I can notice in Husavik the values are similar. And when it comes to Reykjavik, we have whales that show more nicks and more scars than, for example, the ones in Akureyri. And for Husavik, you can already see that the value of the number of whales that will be included is already much higher than the ones in Akureyri. Finally, the body regions that show the most scarring so far are the flanks and the dorsal fin, especially the back part of the dorsal fin. And the head is not as much, but this is likely due to the number of available photos for the heads. Some discussion points that I would like to mention using the data that I have. For example, you can think that once the data is all collected, I will be able to compare the number of resightings throughout the years in different locations, and maybe there are significant differences, but most importantly, matching. If, for example, we see matching throughout between Akureyri and Husavik with Reykjavik, this will already tell us something about minke whale movement, which is not understood, and this could shine some light on this topic. For example, the preference of certain species during whale watch trips, of the humpbacks or the orcas, do have an effect on the capacity of including more minkies in the catalog. Since they have a shy behavior, they tend to only reappear on the surface sometimes and disappear. So this as well already brings a certain bias. And also their behavior, as you can see on the bottom right picture, there's a behavior that the minke whales evolved as an anti-predator strategy. For example, to escape orcas, they spin on their own axis. And this is quite interesting because when they're entangled, they only would make the problem worse, and this will also increase their mortality. Finally, the difficulty in identification for minkies is quite relevant since they don't have the settle patches of orca, they don't have these unique markings, and they don't fluke. So in general, it's quite hard to obtain these high quality pictures that do show distinguishable features. For example, the upper right peak, even this was not included in the catalog because I assigned a value of a 3 out of 1 to 5, but it does show what it appears to be entangled. But since I'm following this protocol, I will not include it. And finally, would be something that would be interesting to see if entanglement and the number of parasites are somehow related. So as the magnitude and severity of entanglement decreases, maybe the parasite load will also increase. In the future, would it be interesting to have a study site in eastern Iceland to cover most of Icelandic coastal waters, even though the whale watching effort it's basically non-existent. So for that point is not something I can include in my work. and also the magnitudes of the indentation. So if this nick is this small and this notch is this big, right now I'm not doing this distinguishing in my study. So maybe in the future this could be something interesting. And all in all, these studies that are supposed to tell us this number of the proportion of minke whales that are showing signs of entanglement, the objective in the end is to make sure that these whales never do get entangled. So this whale deterrence through acoustic means, maybe visual means, could be set up once we know what is this percentage that is being entangled. Thank you very much for being here, and if you have any questions, please tell me, and obrigado.
I have a question.
Yeah.
If you would look at the mortality of whales, is entanglement, does it appear as biggest or one of the biggest causes for the whale death or injured by a human being, like caused by a human being?
So meaning like in cetacean species in general?
Yeah.
Oh. Okay, so the question is if entanglement poses this significant threat to cetacean survivability. And I can tell you in minke whales, this is not as been studied as well, but for example, here in Iceland, the humpegs showed that at least a quarter to half of the individuals showed signs of entanglement, and in the northern right whale, which only 350 individuals are left, the main threat to their lives is entanglement. So it has been observed in many whales, especially baleen whales, that this is a serious problem due to their lives, but also if we focus as well on the ones that do survive but do have these chronic conditions throughout life, if we think, okay, if they die, they die. But what if they survive, but they're not able to reproduce? This also has consequences in the long term. So for sure, I think it's just a major problem for most of the baleen and cetacean species alike. Yes?
Has any work been done with tagging or tracking or anything on that avenue of study?
To my knowledge, I know a situation where 2 minke whales were tagged, but the results were not very conclusive, because one thing in minke whales, they do perform these migrations as baleen whales do, going to the tropics to breed during winter and going to the polar regions to feed during summer. But also some minke whales show these very strong home ranges, and we don't know why. So there must be some variability, but at least here in Iceland, I'm not entirely sure if that has been done to a big amount of individuals at least. All right. Thank you very much.